Hi, my name is Anthony. This is my lab mate, Edmund. And today we're going to be talking about a rechargeable pacemaker. So what is a pacemaker? A pacemaker is a device that regulates the heart's natural beating. Now, why do we have pacemakers again to regulate the heart's natural beating? As we can see on this graph here, over time, pacemakers have been more and more utilized in the biomedical sphere. Specifically, our research is on leadless pacemakers, so that's external to the lead-in ones that you might traditionally think of. These ones are implanted directly within the heart because the heart is quite a complicated mechanism. We don't want to mess up any of the flow states within it. And because of that, the battery tends to be quite small. Because of the smallness of the battery life is quite small. To kind of counteract this problem, our research is looking into harvesting the heart's natural torsion and also its natural compression, such that we may be able to charge these pacemakers. We can see one specific step that we're on is figuring out what the stent design should be. Right, the stent's general concept is that it starts at voltage and it turns into a long linearized state. This then pushes up a magnet, allowing us to create electrical energy. What we see here, though, on the slide is our mechanical bench setup. It is a servo motor turning rotationally and a linear actuator moving back and forth. These in tandem represent the heart's natural linear and torsional motion, which we can then use to conduct fatigue tests on the stent. But turning over to more simulation, long-term side.
So with simulation testing, we are able to get a long-term view of the different forces and stress that the stent undergoes over years and decades of in-heart placement, whereas mechanical testing gives us a more in-person view of how those forces are interacting on the stent. Currently, we're working through an issue with ANSYS simulation software where the sheath and the stent, which are supposed to be attached to each other, are actually detaching in the initial expansion phase of stent delivery. Expansion is when we take the stent from a very small diameter. It's initially manufactured in a small diameter to save material cost and time, and it's expanded into a larger material in order to prep it for delivery. We're currently working on this first stage of stent delivery, and after we're able to fix the errors and able to move forward with this first time of testing, we will work on crimping it back to its delivery radius, which is still bigger than it's initially manufactured to, but smaller than the expansion. Additionally, we hope to look into researching additional stent designs. We currently have this initial bulging design, as Anthony mentioned. And after we develop parameters for a full expansion and crimping test, we hope to do additional research into different stent designs that will allow us to run our tests with not only our own geometry, but also our own stent designs that fit the specific design requirements needed for our rechargeable pacemaker.
Thanks so much for listening.
Okay.